let's talk about what? The torsional pendulum. So basically, the torsional pendulum is one of the system of what? Simple harmonic motion. It's a system that what? Undergo what? Simple harmonic motion. Now, the torsional pendulum is just like the discs tied to a rope, and that rope is suspended to the ceiling. So what happens? What happens is you are going to apply a force. You are going to apply a force that is going to what? Allow the what? The flat disc to rotate. So basically, you are applying the force here, and what happens? When you apply the force, the disc is going to what? Rotate. And when we are considering what? Rotation, in that case, it is twisting. When we are considering twisting, what are we considering? Torque. Because your torque is the product of what? Force and what? The rotation. And remember, when your disc is rotating, there will be an angle of what? Displacement. That is why on this case, we have what? Theta to be what? Theta mass. And here we have theta to be what? Minus theta mass. Am I communicating? So basically, what's the concept? The concept is torque. Torque is directly proportional to the angle of what? Displacement. When we have this sign of proportionality, we remove the sign of proportionality and introduce what? An equal to sign. So basically, we now have that our torque will now be equal to minus k theta, where your k now stands for what? Torsional what? Constant. Your tau here simply stands for your torque, and theta here simply stands for what? Angle of what? Displacement. Remember, from our elementary physics, we know that but torque is the product of what? Moment of inertia multiplied by what? Angular acceleration. From our elementary physics, we know that what? When we are considering torque, we are considering moment of inertia multiplied by what? Angular what? Acceleration. So basically, in this case, anywhere you see torque, we are replacing it with what? I alpha. Am I communicating? So basically, you have I alpha is now equal to minus what? K theta. So we can call this equation 1 and we can call this equation what? 2. Remember, when we are talking about acceleration, when we are considering what? SHM, our interest is to get the differential for what? Acceleration. So I told you earlier that acceleration is the second differential of what? Velocity. We know velocity as what? Velocity is the product of what? Dx over what? Dt. And we prove that acceleration is now the product of what? The second derivative of what? Of velocity, which is d square x over what? Dt square. So basically, in this case, where we are seeing our alpha, what are we substituting? We are basically substituting d square x over what? Dt square, because it is what? Acceleration. So basically, we know that, but acceleration is what? D square x over what? Dt square. Dt square. So basically, what was this? So what we have here is basically I multiplied by, in this case, we are not taking alpha we are not taking alpha to be, we are not just taking alpha, but what are we considering? We are considering alpha to now be the second differential of what? Velocity. So we have d square what? X over what? Dt square, and this is equal to minus what? K theta. Let's call this equation 3. Now, I told you earlier that when we have second differential of this to be, second differential of acceleration to be what? D square x over what? Dt square multiplied by what? Moment of inertia. I told you that always take this to stand on its own. Let this remain on its own. Now, for this to stand on its own, what are you simply doing? You are simply dividing through by what? Moment of inertia. So we basically have that to be I, which is moment of inertia, multiplied by d square x over what? Dt square, and this is equal to minus k what? Alpha. What do? You divide through by what? I here. You divide through by what? I. Am I communicating? So if you do this, this is simply, we are simply left with what? D square x over what? Dt square, and this is equal to minus what? K divided by I theta. Am I communicating? Now remember, in our elementary maths, when we have something like minus 2x divided by y, this can also be written as minus 2 divided by y multiplied by what? X. Now let's apply this concept here. Applying this concept here, we have that your d square x over what? dt square is now equal to minus what? K divided by I multiplied by what? Alpha. But remember, recall, we have w square is equal to k divided by what? I. So basically, we are using w square to represent what? K divided by I. So in a place where we are seeing k divided by I, which is torsional constant divided by moment of inertia, we are representing it with what? W square. So we can say that this is written as d square x over what? dt square, and this is equal to minus w square theta. Now what's the next thing? You have this to be this. Take this back to this other side of your equation. Take this, cross it over to your equal to sign, and equate it to 0. So this will now be written as d square x over dt square plus w square theta is equal to 0. So basically, if you go back to your simple harmonic motion, you'll see that your simple harmonic motion have this what? This concept, which is d square x over dt square plus w square theta is equal to 0. Go back to your simple harmonic motion that we proved earlier. You see that it still have what? This concept involved. It still have what? This equation. When I mean concept, it still have this equation too. Now I told you that this, your second differential in some cases, can be written as y prime prime of what? X. But in this case, we have what? We are differentiating x with respect to what? T. So in this case, you simply have s dot dot with respect to what? T plus w square theta is equal to 0. Now this is what? The equation for what? Simple harmonic motion. That's why we said what? Your torsional pendulum is an example of what? The simple harmonic motion.